Welcome, Hornets, and thank you for joining me today. Today we're going to be talking about series. Now, a series is simply a sequence of terms added together. And we have different types of series. The two most general topics would be an infinite series, or a series that doesn't end, and a finite series, a series that has a beginning and an ending. Now, you'll notice on the screen in front of you, I have a sequence written down as 5 plus 11 plus 17 plus 23 plus 29 plus dot dot dot. The dot 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 identifies it as an infinite series. And if we were to write it as a series, we would have 5 plus, 11 plus, 17 plus, 23 plus, 29 plus dot dot dot. Now, we can always find the rule that gave us the sequence. And the rule that gave us the sequence can be found by finding our difference between the terms. And you'll notice the difference between each term is 6. And the first term is a sub 1 equaling 5. We can then put it into our formula. A sub n equals a sub 1 plus our common difference times n minus 1. Since we know that we have our a sub 1 as 5, our common difference is 6, we can then find our rule and say we have 6n minus 1. And this is our a sub n. Notice when we plug in 1, we get our 5, and when we plug in 2, we get 11, and when we plug in 3, we get 17, and when we plug in 4, we get 23, and plugging in 5 will give us 29. Well, that means that our series can be written in terms of a summation. Now, a summation is just another way of representing a series. And you'll notice that we have our rule, and what we're looking at is plus a 6n minus 1 plus dot dot dot. Now you'll notice this is going from 1, a sub 1. We use I. So the rule is going to be 6i minus 1. And we're going to infinity. Okay. Now if we were just going to n, we could go 1 to n. All right, whatever that is. But this is what we're talking about. We have a series and we have a rule. Now, we can use all kinds of different rules, and you've seen quite a few different ones over the last little bit. And those rules can be all kinds of things, from quadratics. So, for example, let's say we had something that was 3, 5, 7, 9, 11, dot, dot, dot. And then on top, let's put a 1, 4, 9, 16, 25. Now, this series written, or this sequence written as a series would be 1/3 plus, 4/5 plus, and let's not go dot, dot, dot. Let's just stop. So we have a finite series. 9/7, 16/9, 25/11. The rule, we have a quadratic on top, n square. Let's do in terms of I. So I'm going to do n squared will work, over, our rule here is 2n plus 1. So when we're writing it as a summation, we would be looking at the summation from I equaling 1, 1, 2, 3, 4, 5, up to 5 of our rule, I squared, over 2i plus 1. Now, in order to find out what this sum is, we would just simply add these terms up. So we're really just looking at this. Now, any sequence can be turned into a series by simply adding the terms together. And if you can find the rule of the sequence that generated that series, you can find what a summation is. Okay? So once again, this is a general sequence turned into a series, and any sequence can be turned into a series by adding up the individual terms. If it goes off infinitely, it's called an infinite series. And if it stops, it's called a finite series. We can also call it a definite series. Okay? Alrighty. I hope this has helped you to understand the basics of what a series is and ultimately what a summation is. Just a sum of the terms of a series, starting at a specific term and ending at a term. Okay? If you liked this and found this useful, please remember to click like. If, however, you feel you have constructive criticism, please feel free to give me constructive criticism. Thank you very much, Hornets, and cheers. Bye-bye now.